In the name of God, hello dear students, my name is Masoud, I'm a physics teacher. We are in Ferkhwa's website to explain physics curriculum. So far we finished the explanation of section 1-3 for chapter 1 in grade 11. Right now we are going to answer and discuss some questions regarding the third section. Right. Let me read the first question for you. If a hammer and a feather released from the same height above the lunar surface, above the moon's surface, we have a space, we have a gap here. A space would land on it. We have another space. So there are two gaps. We have to fill in the gaps with appropriate options. A, it says, let's say, if a hammer and feather released from the same height above the lunar surface, hammer would land on it firstly. Is it true? B, feather would land on it secondly. C, both objects would land on it simultaneously. D, A and B are correct. A and B are correct means hammer land on lunar surface firstly, and after that, feather lands on it secondly. Is it true? So it doesn't make sense. Only C is true. Both objects both objects would land on lunar surface simultaneously because moon does not have any atmosphere. So any motion above the surface of moon is considered to be free fall, and all of the objects fall with the same rate. They pick up the same acceleration, which is the acceleration due to gravity of moon. Question number 2, both of the feather and hammer land on the moon's surface simultaneously. Both of the feather and hammer land on the moon's surface simultaneously. So he revealed a fact for us. When they release from the same height, because. So what's the reason of this demonstration? What's the reason of this experiment? You know that this experiment was taken place by David Scott, which is an American, he was an American astronaut. He did this experiment over the surface of moon in 1971. So what's the reason? Why do feather and hammer land on the surface of moon simultaneously? Let's read the reasons. A, they both travel the same displacement in the same time. Yes. B, they both travel the same acceleration. Yes. They both have the same acceleration. Yes. C, they undergo the same amount of force. It doesn't make sense because the force that is exerted on the hammer is greater than the force that's exerted on the feather. Keep in mind that force of actually gravitational force is not the same for feather and hammer. I can say any planet applies a greater force for heavy object and applies a less amount of force on light object in order to give the objects same acceleration based on the Newton's second law of motion. Based on this law, A is equal to F over M, right? So heavy, let's say a larger force over heavy object. For example, a smaller force over lighter object. That's why these actually condition counteract one another, and acceleration remains constant for all the objects, let's say, moving on the planet. That's why A and B is true, right? Option D is true. It says A and B are true because they both travel the same displacement. Yes. They both have the same acceleration. Yes. Freely falling objects undergo, we have two options. variable acceleration or constant acceleration. Of course, they undergo constant acceleration at high altitudes. At high altitudes near the surface. So we have two options: either at high altitude or near the surface of a planet. All objects fall with the same constant acceleration in the absence of air. In the absence of air resistance or air, at high altitude or near the surface of any planet, of course, near the surface of any planet. Right. Number 5, the motion of a parachutist at high altitude is or is not considered free fall because of, what's the reason? Actually, because parachutists uh, exist at high altitude, that's why its motion, uh, that's why its body or its parachute, I can say, undergo uh, undergo the air resistance. Uh, they are exposed to, actually, its body or and its parachute, his body or her body, and actually his parachute, I can say, is exposed to what? Is exposed to the air resistance. That's why the motion of parachutists is not considered free fall because of what? Because of air resistance, right? You have to fill the gaps where with air resistance. Number 6, space. We have a gap here. All objects fall with the same constant acceleration near the surface of a planet. All objects fall with the same constant acceleration near the surface of Earth. So what's the condition? In the absence of air resistance, all objects fall with the same constant acceleration near the surface of a planet. Right. I can say in the absence of friction, in the absence of air resistance, excuse me. And air resistance belongs to friction, but you have to mention the exact expression: in the absence of air resistance, you have to fill the gaps with this expression: in the absence of air resistance. Right. Let's move on to question number 7. Question number 7, it says the free fall acceleration. The free fall acceleration is denoted with the symbol, or is denoted by the symbol or with the symbol. What's the symbol of free fall acceleration? And its magnitude is approximately space at the surface of Earth. Actually, we denote the free fall acceleration with G small. We symbolize the free fall acceleration by G small, and its magnitude approximately on the surface of Earth is equal to negative 9.81 meter per second squared. Right. Question number 8. The acceleration due to gravity, or G, is directed downward or upward toward this positive y-axis or center of Earth. So we have two gaps. Each gap includes two options. The acceleration due to gravity, or G, is directed whether downward or upward. Which one is correct? Either downward or upward. Of course, I told you without thinking, acceleration due to gravity is always negative. That's why it's directed downward toward the positive y-axis or center of Earth. Of course, toward the center of Earth, in the opposite direction of positive y-axis. It means toward the center of Earth. Number 9, in the absence of air resistance. Right. All objects fall with the same acceleration regardless of what? In the absence of air resistance, whenever you evacuate the air, all objects fall with the same acceleration, regardless of their masses. Regardless of their masses. Question number 10. I'm gonna, let's say, complete the questions. Question number 10. At the peak of the path shown in figure below, we have a figure below, this figure. We have the same experiment that I did it for you. Whenever you throw the ball up and after that it moves down. So we had a simple experiment. At the peak of the path shown in figure below, the ball's acceleration is either 0 or negative 9.81 meter per second squared, and its velocity is 0 or negative 9.81 meter per second, respectively. Actually, whenever you do this experiment, the object moves, the object stops for a while at the peak of the track, at the very top of the path. The ball stops its motion, stops from motion. That's why, but keep in mind that acceleration does not become zero for free fall, even when the object stops from actually from motion, because acceleration is not actually is not taken just by one value of velocity. Acceleration is the change in velocity, right? That's why zero velocity, only one value of velocity, and it doesn't give us an acceleration. That's why you have to subtract the zero velocity from next velocity in order to get the acceleration accurately. That's why don't confuse it. Acceleration of free fall does not become zero, but velocity becomes zero. Actually, it's okay. It's normal for velocity to be zero, but it's not. Actually, it doesn't happen. And acceleration, it's not zero for free fall bodies. That's why acceleration is negative 9.81 meter per second squared, but velocity is equal to zero at the peak of the track. Number 11, when an object is thrown up in the air. When an object is airborne object, when an object is airborne, what's the airborne means? Up in the air. When the object is thrown up in the air, it has a positive or negative velocity and positive or negative acceleration. Right. Think about actually think about the same example when the ball is thrown up into the air. Right. It says it has a whether positive or negative velocity. Of course, I'm sure you know the answer. It has a positive velocity and positive or negative acceleration. Keep in mind that acceleration due to gravity for any planet is always negative. It doesn't take positive value. Number 12, when an object is thrown up in the air, like this ball, right? When the object, tennis ball, is thrown up in the air, it means that the object is or is not in free fall. Of course, I told you free fall is of two types, whether you throw the ball up or whether the ball is fell down. These cases actually are considered to be free fall. So free fall does not mean fall down. It means vertically motion of any object under the effect of only gravity, actually neglecting the retarding forces. So when an object is thrown up in the air, it means that the object is in free fall. The object is in free fall. Number 13, when an object is fell down, like this. When an object is fell down in the air, it means that the object is or is not in free fall. The object is free fall as well, because free fall, I told you, is of two types: throwing up and falling down vertically over the surface of any planet. Number 14, when an object begins moving down in the air, like the ball that begins moving down in the air, it has space velocity and acceleration. When an object begin moving down in the air, so the object has negative velocity and acceleration, A, negative velocity, B, constant velocity and acceleration, C, A plus B means constant and negative velocity and acceleration, D, positive acceleration and velocity. Actually, only A is true, because acceleration is constant, but velocity does not velocity is not constant. Velocity does not become constant. Velocity is changing by the constant value. So the velocity is increasing in the case of actually moving down the object. Velocity is increasing, but by the same amount. So the only thing that is constant or is only acceleration. Displacement is changing. Velocity is changing, but the change is taking place uniformly. You can predict the next situation, but the only factor that remains constant is only acceleration. That's why the common answer for both of velocity and acceleration is just negative direction of acceleration, and actual velocity is negative when the object moving down, let's say, toward the center of planet. Thank you very much, guys, for watching this video, and bye bye.